solve this equation. I get to think back on how I solved equations. My first question is, are both sides simplified? They're basically simplified. If you like to leave chain change, go ahead and leave chain change right there. Okay, then I got to ask myself, are the variables on one side? Oh, I've got variables on both sides, 4x and 5x. So remember, I'm going to look for the one that has the smaller coefficient, and I'm going to move it, or really get rid of it from this side and put it over to that side. So the way I can get rid of this 4x is I can subtract it. I do it to both sides to keep them balanced. So I'm left with 1x plus negative 3 equals 0. This, get rid of that, equals 7. Good. Now I need to isolate x. I need to get it by itself. So I'm going to add 3 to both sides. And I end up with 1x is equal to 10. Same thing as x is equal to 10. And that's my solution. I can check real quick. 5 times 10 minus 3 should be the same as 4 times 10 plus 7. Let's see, so it's 50 minus 3 should be the same as 40 plus 7. And that's true. So 47. Yes. Solve this equation. Okay, here we go. 4x minus 2 times x plus 1 equals 4. First thing I got to do is simplify, because this side is definitely not simplified. So I'm going to leave chain change that. Now I have to distribute this negative 2. I'm going to end up with 4x plus negative 2x plus, remember, negative 2 times 1 is negative 2. I'm going to combine like terms. Got an x term here and an x term here. So that's going to end up being 2x plus negative 2 is 4. I'm going to get rid of my negative 2 by adding 2. The opposite of negative 2 is positive 2. And I end up with 2x is 6. Divide by 2, and I get x is equal to 3. Let me check that and make sure that that's right. 4 times 3 minus 2 times 3 plus 1 should give me 4. I'm just plugging the value of x in, value of 3 in for x. So that gives me 12 minus 2 times 4 should give me 4. I'm going to multiply first. 12 minus 8 should give me 4. 4 equals 4. Checks out. My answer, x equals 3. Solve for x. More solving. So good at solving. All right, first thing I'm going to do is leave chain change. Oh, I love this. So I'm subtracting this whole polynomial inside the parentheses. So this is going to be plus negative 1. Negative 3. It's negative 2. Here we go. So now I have to distribute this negative 1. 4 plus, okay, negative 1 times x is negative 1x plus negative 1 times negative 3 is positive 3. Anything else I can do? I can combine like terms before I start to solve. So I've got a constant and a constant. Let's combine those. So 4 plus 3 is 7. So I end up with negative 1x plus 7 equals 2 plus negative 2x. Okay, do I have variables on both sides? Oh, I do. I've got to get them to one side. I'm going to find the one that has a smaller coefficient. And then add its opposite. What's smaller, negative 1 or negative 2? Negative 2 is smaller, so we're going to get rid of the one on the negative 2 side. So I'm going to add 2x to both sides. Didn't mean to do that in blue, but it's not on the wild side. And I end up with 1x plus 7 equals 2. Now I'm going to subtract 7 from both sides. So I'm isolating x. I want to get x all by itself. And I end up with 1x is equal to negative 5. Let's check and see if that works out. 4 minus negative 5 minus 3 should be equal to, no, 2 minus 2 times negative 5. Wow, it's a lot of stuff. Okay, so I've got 4 minus negative 5 minus 3 is negative 8 equals 2 minus 2 times negative 5 is negative 10. Leave change. Oh, leave change. 12 equals, oh yeah, here we go. Checks out. Last one. Solve the inequality. Oh, I love inequalities. Get bigger. Do this basically the same thing as when you're solving equations. There's just one exciting thing that you've got to consider. So let's go ahead and solve this. So I've got negative 2. Okay. So I'm going to distribute 5 plus negative 2 times x, negative 2 times negative 3. Negative 2x plus negative 2 times negative 3 is 6. Writing down that inequality is greater than 13. Good. I'm going to combine like terms. I got some constant values here I'm going to combine. So I end up with negative 2x plus 11 is greater than 13. Now I'm going to isolate that x. I'm going to subtract 11, or add the opposite of positive 11, so minus 11. And I'm left with negative 2x is greater than 2. Almost, x is almost isolated. Okay, so now I'm going to divide by negative 2. Anyone hear anything? Woo! Remember, we got to flip that inequality whenever we are multiplying or dividing by a negative. Yay, I get to flip it. When I mean flip the inequality, I mean I'm actually flipping this inequality sign. If it's greater than, it's going to become less than. So I end up with x is less than 2 divided by negative 2 is negative 1. X is less than negative 1. So when I graph this, I've got to show all the values on this number line that are less than negative 1. Let's see, I'll make it negative 2, negative 1, 0, 1. So this is my number line. So does it include negative 1? No, it doesn't include negative 1. So that's going to be an open circle. Now, where are the values for x that are less than negative 1? On this side right here. All these values are less than negative 1. And now it's graphed. And now you're done.